Okay, remember that you should try to isolate your radical before raising both sides to the same power. That power would be the same as the index of the radical. However, you may not always be able to isolate, as we saw in the last example. In any case, after you solve the new equation that you get, you should check, because you don't always have the solutions to the new equation equaling that set of solutions won't always equal the set of solutions to the original equation. The set of solutions to the original equation would be a subset of the solutions to the new equation. So here, if I were to add 3 to both sides to isolate this square root, then this square root would not be isolated. So I'm going to go ahead and square both sides right away. Now, the left-hand side, we have to be very careful. We're going to wind up squaring the 3 minus 7p under the square root. We're going to wind up squaring the 3, but in between, we're going to have minus, because of the minus 3, 2 times 3 times the square root of 3 minus 7p. If you're not familiar with this shortcut, and I was showing it in some earlier videos here, then multiply it as the square root of 3 minus 7p minus 3, put parentheses around it, multiply it by itself, and use FOIL. On the right-hand side, it's a lot quicker. The squaring just cancels out the square root. Same thing here for that first part. At least we only have one square root now. I'm going to combine like terms by adding 7p. Well, let's first add the 3 and the 9 on the same side. Then let's go ahead and add the 7p and subtract the 12. And since all of these are even, I could divide by 2. Again, I still have a square root here, but we're only multiplying something to it. So let's square both sides. Because when you have multiplication, you could square the individual parts. So 9 times the quantity, 3 minus 7p. Either FOIL this out, 7p minus 5 times itself, or use that special formula. 7p squared would be 49p squared. 7p times negative 5 is negative 35. We have to double that. Followed by negative 5 squared is 25. So distribute on the right-hand side. And then we'll do one last bit with combining like terms. 9 times the 7 minus 63p. All right, so if I subtract 27 from 25, I'll have negative 2. If I add 63p to negative 70p, I'll still have negative 7p. And then there's the 49p squared. To solve this new quadratic equation, you could use the quadratic formula or factor. I use something, when possible, called the AC method, followed by grouping. I could list various factor pairs that would multiply to negative 98 and look for one that adds up to negative 7. Actually, I already know, somehow it just hit me, that negative 14 plus 7 would give us negative 7, and negative 4 times 7 would give us negative 98. So I use that to split up the middle term. From the first two, I can factor out a 7p, which would give me 7p minus 2 as the other factor. I can only factor out a 1 from the second group. 7p minus 2 is common. And so the other factor is the 7p and the plus 1 the 7p minus 2 was multiplied to. Finally, the only way you can multiply two things and get a product of 0 is if one of the factors is 0. Solve these two linear equations, and we get two possibilities, that p equals 2/7 or p is equal to negative 1/7. If you're not familiar with the AC method and grouping to factor the quadratic, then do something else to try to factor it or use the quadratic formula. Let's check both the 2/7 and the negative 1/7. So we check p equals the positive 2/7. The nice thing is that wherever we see p, it's being multiplied by 7, which will cancel out. So we'd have 3 minus 2 under a square root minus 3. We want to know if that is equal to, same deal over here, 7 times 2/7 is 2 again. So under a square root, 2 plus 2. It's going to give us the square root of 1 minus 3. We want to see if that's equal to the square root of 4. And on the one hand, the left side is negative 2. The right-hand side is positive 2. So we're going to reject the answer of positive 2/7. So if there are any solutions, the only other candidate is the negative 1/7. Same deal with that denominator of 7, multiplying by 7 here and here. The only places we'd be plugging p in. Negative 7 times negative 1/7 would give us positive 1. 7 times negative 1/7 would give us negative 1. We want to see if these two are equal. Square root of 4 minus 3. Is that equal to the square root of 1? So we'd have 2 minus 3. We want to know if that's equal to 1. No. Negative 1 is not equal to positive 1. So we're going to reject the negative 1/7 as well. Those were the only two candidates. So we would conclude there are no solutions to the equation that we started with. Sometimes that gets abbreviated with something that looks like a 0 with a slash mark through it. It's not a 0. It's the symbol for the empty set.